This is the Pre-Calc Honors Semester 1 review, problems 13 to 24. Number 13 asks you to solve by graphing y equals negative 13x cubed minus 7x squared plus 10x. First of all, if you just notice it has a greatest common factor, you're going to figure out real fast that one of the solutions has to be x equals 0. But the other two solutions are going to be irrational. The easiest way to do that is to put this equation in y1 equals, and in y2 equals put 0. So instead of finding the 0 using the 0 function, which can be a little testy at times, instead you're finding where your graph intersects the x-axis, because it's the graph of the x-axis, and instead you'll use the intersect function. All you have to do is get the cursor close to the point of intersection you want to find. So you should find the other two solutions, not a y, are approximately negative 1.19 and approximately 0.65. And it should have also hit at 0. Problem 14, use synthetic division to divide these two polynomials. Negative 7x cubed plus 20x squared minus 13x plus 10 divided by x minus 2. So first you have a little box over here, and to find out what number goes in that box, you set this equal to 0 and solve for x. Positive 2 goes in the box. Next to the box, go to the coefficients of the polynomial you're dividing into. Don't forget to ask yourself if there are any missing terms in the polynomial. Whatever the biggest exponent of x is, each consecutive coefficient should be 1 power less than the previous one. Well, I have x cubed, x squared, x to the first, and no x, so I'm not missing anything. So negative 7, 20, negative 13, and then 10. So bring down the first term and then multiply, and then add, and then multiply, and then add, and then multiply, and then add. The quotient is always 1 power less than the original polynomial you divided into. There are a couple different ways of writing the final answer, and I'm not sure which one's on the final exam, so I will give you all three. One of them is to write negative 7x squared plus 6x minus 1 with a remainder of 8. That's probably the original way that you learned how to do this problem. You may also have learned this, negative 7x squared plus 6x minus 1 plus 8 over x minus 2. And the third way, the one our Pre-Calc Honors book introduced, was divisor times quotient plus remainder. So it would be x minus 2, negative 7x squared plus 6x minus 1 plus 8. One of those would be the answer to the problem on the final. I'd love it if the graphing calculator did all of my math for me, but unfortunately it doesn't. And sometimes you have to come up with other algebraic ways of solving polynomials. So in order to solve 5x squared minus 84 is equal to negative x to the fourth, the first thing that I'm going to do is I'm going to put the equation into equals 0 format. Just add x to the fourth. So it's x to the fourth plus 5x squared minus 84 is equal to 0. If you graph it in your calculator, you're going to notice that the graph hits the x-axis twice, and the solutions are nasty decimals. But what if I want to find the exact solutions? Well, what I want you to notice is anytime you have a polynomial whose first term is an even power, and the second term, the exponent is half the first term, we say it is a polynomial in quadratic form. That means it factors like a quadratic. That means you find the two numbers that multiply to give you this and add to give you this. But when you write your two binomials, it's just not going to be x and x. It's going to be x squared and x squared. The two numbers that multiply to give you negative 84, but when you add them give you 5, are going to be positive 12 and negative 7. And you could play around to figure that out. Now I'm going to do the zero product properties. So x squared plus 12 is equal to 0, so x squared is equal to negative 12. When I square root that, I'm going to get x is equal to positive or negative I square root of 12, but square root of 12 can be simplified into 2 radical 3, and you can put the I here. You can put the I at the end. I want to say that traditionally it's written at the end. The other two answers, x squared minus 7 equals 0. This is where my real answers are going to come from. Add the 7, and when you square root it, you'll notice square root of 7 is a real number. It's a nasty decimal, but it's a real number. And it's going to be plus or minus. Problem 16 says, if you invest $2,500 at an interest rate of 0.8% compounded continuously, and this is the equation for continuous compounding, how much will you have in 12 years? So the amount you'll have in 12 years will be $2,500, e raised to the 0.008 times 12. The one thing you always have to watch out for when doing these problems is what is the interest rate in decimal form. So there are two ways of doing it. You can either divide the rate by 100, or just remember that it means move the decimal 2 places to the left. Since this is a money problem, we're always going to round to the hundredths place because that's to the nearest penny. And it turns out it's going to be about $2,751.90. How long until your investment doubles? Well, you know that when your investment doubles, you'll have $5,000. So now you just want to solve for t. Nothing else changes. So first you would divide by 2,500, and hey, look, you get 2. In order to solve this, we have to do the inverse operation of e. And the inverse operation of e is the natural log. So the natural log of 2 is going to be 0.008t. And then we'll divide the natural log of 2 by 0.008. And we'll find out it will be approximately 87 years before my money doubles. Problem 17, let's simplify this expression into a single logarithm. 7 log base 5 of a minus 2 log base 5 of m. When you are simplifying into a single log, the first thing you're going to do is you will always get rid of any numbers in front of the log. Our properties of logarithms say that they become an exponent. Now, the properties of logarithms say that if you're subtracting 2 logs with the same base, you combine them into a single log by dividing. And that would be the answer. There's nothing more you can do. Number 18, evaluate the log base through 32 on your calculator. There are a couple different ways of doing this. If under the math menu on your calculator you have log base, it would be under math. And then if you scroll up, you would find it. You can just type in 3 here, 32 here. It'll spit out the answer. If you don't have that function on your calculator, you can use the base change formula. The base change formula is log of 32 over log of 3. Because what we did was we changed the base to be base 10. Now you can plug that in your calculator. But base 10 is not the only log we can convert it to. We can also convert it to the natural logarithm. You will get the same answer if you do the natural log of 32 divided by the natural log of 3. Any of those 3 methods should result in 3.1546. Number 19, solve for x. 10 to the 4x is equal to 8. You have a couple options here. One of the options is if you're not sure how to do the problem algebraically, you can always put one side of the equation, y1 equals, put the other side in y2 equals, and the solution is the x-coordinate of the point of intersection. Or, algebraically, we would rewrite this in log form. It would be log base 10 of 8 is equal to 4x. Because this is base 10, you can shove it in your calculator real fast and get 0.9031. And then divide by 4, and we find out that the answer is 0.2258. which is the same answer you would get if you were to graph both sides and find the point of intersection. Solve for x in number 20. 3 log 5 minus log 3 plus 2 log x minus 2 equals 0. Again, you have a couple options here for solving. you could put this into y1 equals, this into y2 equals, and since y2 equals 0, your solution would be the x-coordinate of the point of intersection with the x-axis. So in other words, it would be the x-intercept. Or, to do this problem algebraically, you would first get rid of any number in front of a log by making it an exponent. I would take that minus 2 and add it to the other side. So this is log of 125 minus log 3 plus log x squared equals 2. Then from left to right, I would simplify the logs using the property of logarithms. This is going to be log of 125 over 3, which is not reducible. And then the property of log says if you're adding, you can combine into a single log by multiplying. And then I would rewrite this in exponential form, which would be 10 squared, because that's log base 10, is equal to 125 over 3x squared. So this is 100. And to get rid of the 125 over 3, you would multiply the other side by the reciprocal. So now I get x squared is equal to 2.4, and then you would square root this, and since you're square rooting it, you're going to get two answers, and they are going to be plus or minus 1.5492. And if you had graphed the original problem on your calculator, you would have seen the graph hit the x-axis twice. Or I lied, because it doesn't hit twice, because you can't take a log of a negative, so it can't be negative. Sorry about that. It has to be positive, because if you plug it back into the original problem, you cannot take the log of a negative. In problem 21, I want to find the asymptotes of this rational equation, 2x over x squared minus 7x minus 18. First, if you can factor the numerator or denominator, you do it. The two numbers that multiply to give you negative 18, but add to give you negative 7 are negative 9 and positive 2. The vertical asymptotes are the values of x that make the denominator equal to 0. In other words, do the zero product property on the denominator. So x is going to equal 9 and negative 2. The horizontal asymptote, we had rules for finding the horizontal asymptote. If the largest exponent of x in the numerator and denominator are the same, then the horizontal asymptote is just the ratio of the coefficients of those terms. But what if the largest exponent of x in the numerator and denominator aren't the same? Well, if the bigger exponent of x is in the denominator, then the horizontal asymptote is y equals 0. If the bigger exponent of x had been in the numerator, there would be no horizontal asymptote. In number 22, for the sequence, 8, negative 1, negative 10, negative 19. First, determine if that sequence is arithmetic or geometric, and then find the common difference or the common ratio, depending on which one it is. And in part B, we're going to find the 50th term. Don't worry, these formulas will be given to you on the final. So, it's arithmetic if you have to add or subtract to get to each consecutive term. And it's geometric if you have to multiply or divide to get to each consecutive term. I always check for arithmetic first. So this is minus 9. And hey, look, this is minus 9. So it must be arithmetic, and the common difference is negative 9. So now if you want to find the 50th term, you would pick the equation for the nth term of an arithmetic sequence. So the first term was 8 plus 50 minus 1 times negative 9. Shove it in my calculator, and I would get negative 433. Number 23, for the sequence 1/2, 1/8, 1 over 32, determine if it's arithmetic or geometric, find D or R, and then find the 6th term. You can usually take a guess that if the terms are fractions, it's probably geometric or it's neither. So if it's geometric, the common ratio is really easy to find. You take the second term and divide it by the first term. 1/8 divided by 1/2 is 1/4. If 1 over 32 over 1 over 8 is also 1/4, then it's geometric and the common ratio is 1/4, which it is. So to find the sixth term, we're going to use the nth term of a geometric sequence, which is the first term times the common ratio raised to the n minus 1 power. So the first term is 1/2, the common ratio is 1/4, raised to the 6 minus 1 power. Plug it in your calculator, hit math, enter at the end, and you'll find out the answer is 1 over 2048. Number 24, for the series, -4 minus 1 plus 2 plus 5 plus ... We're going to use summation notation to write this for adding 15 terms of this sequence. The way that works is, here's sigma, and the bottom number is going to be 1, and the top number is going to be 15. What that says is add the first 15 terms. So n equals 1 would be the first term of the sequence. N equals 2 would be the second term of the sequence. Well, now we have to find an algebraic expression to represent the sequence. So what I do is I try to determine if it's arithmetic or geometric, because if it is, this is pretty easy to do. So I notice that this is plus 3, so it must be arithmetic. If it's arithmetic, I'm going to use the formula for the nth term of an arithmetic sequence to write my algebraic expression. I don't know what n is, which is fine because I need a variable in my expression. So the first term is -4. I don't know what n is, but I do know the common difference is positive 3. Try that again. There we go. And now I'm going to simplify that expression to put in summation notation. So I distribute, and then I combine like terms. So, in summation notation, this would be the sum of 3n minus 7 from n equals 1 to n equals 15. And that's the semester 1 review, problems 13 to 24.